Hello students. So today we will learn about the computer organization that we are going to start the course on computer organization. The code is the TCS 404 and we will discuss in this session about the syllabus discussion and about the things that what we are going to deal in the computer organization in the current semester. So this is my introduction, and I am Dr. Gaurav Verma. I am PhD from Gautam Buddha University in Energy Harvesting Systems, and my MTech is in VLSI Design, and my engineering is in BTech ACE. So my research publication, you can find my research publication in my Google Scholar in the link that I have given you. And in my current research topic, my current research topic is on energy and Internet of Things and wireless sensor network. I have 4 patents on energy and wireless sensor networks and then some Internet of Things type of things and projects. So in the course outcome of a computer organization is to understand the basic components of a computer and milestone in their historical development, and the discuss the operation of the arithmetic unit, including the logarithms and implementation of a fixed point and floating point addition, subtraction, multiplication and division. So we will discuss that how the algorithms are working, different algorithms are working on the hardware and how they are working actually when we are going to deal with the hardware of the addition, subtraction, multiplication and division for the floating point and non-floating point numbers, and have a clear understanding of elements of CPU working and instruction set architecture. So we will discuss about the CPU working and that how the CPU works actually and how the instruction set architecture works. So next is we identify the impact on the hierarchical memory system, including cache memory and virtual, on the overall computer system design. So we will discuss cache, how the cache memory works, how it affects the speed of the system, and what are the basic system, what are the basic structure for this. So we will discuss all these things. So next we will discuss the input output architectures, and we will evaluate the various aspects of the input output operations also. And next we will find that how their overall performance and the functioning of the computer works. Next, in the last, we will discuss about review the current trends in the development of the processor architecture and emphasis on the instruction level, parallelism, latency, preparation in the pipeline design, and fault tolerance. So because the architecture and the processors are important to understand that how the current systems are designing, so we will discuss these things also, that what are the current trends and what will be the future trends. This must be known by an engineer. And definitely when we are going to discuss about the artificial intelligence and machine learning type of things, then this is very much important that to understand the processor architecture and how this architecture works actually. So next we will discuss about the detailed syllabus. So detailed syllabus of Graphic University and is as follows for the computer science department. And in this case we will find that first is the unit which generally include the basic structure, basic introduction, and in the introduction you will find the main components of the computer, historical development, that how the computer develops. History is very much important to know that in the first case that how the computers works, and these days how the computer works, because if you don't know the history of the computers, then you cannot develop a very good system. Okay, so next is Moore's law. Moore's law is important to understand that how the technology is going it is also providing us the miniaturization of the technology, I can say. Okay, next is the von Neumann and non-von Neumann models, that which type of the models of the computer hardware are present in the market, and the evolution of the Intel x86. Intel is one of the company which explore itself in the domain of the microcontrollers and microprocessors. So it is important to us to understand that what is the Intel x86 architecture and how it evaluates in the market. Next we will discuss in the unit 1. This is the part 1 of the unit 1, and next in the next part of the unit of the same unit we will discuss about the data representation in computer system, that how a computer system works on a data representation. So sign integer representation is we will know the sign integer representation, complement systems, ones complement and twos complement, addition and subtraction using signed numbers, and multiplication of positive numbers, signed operands, multiplication, integer division, floating point representation, the IEEE 754 floating point standards, that we will understand that how these floating point numbers are stored in a computer memory. Okay, so floating point arithmetic, that how the floating point arithmetic works actually, and floating point errors, that when errors comes then what happens in the computing system. Okay, in unit 2 we will discuss about the machine instruction and program, that how machine instruction and programs works. So memory location and addresses are, we will know about the memory location and addresses. We will learn about memory operations, instruction and instruction sequencing, that how many types of the instruction we have and how we work on these instructions, addressing modes and execution of a complete instruction, single bus organization or control unit operations, and instruction sequencing, micro operations, and register transfer hardwired control. So we will learn about these things in this part, and there are also two parts. One is the machine instruction and programs, and another is performance. So in this we will also learn about micro programmed control, basic concept, micro instructions, and micro program sequencing. So next part is your performance of the system, how the performance works. Performance depends on the processor clock, basic performance equation, clock rate, performance measurement, concept of pipelining, and Amdahl's law. So Amdahl's law provide us the performance, that how this performance works of the single computing, we can find the performance of a system. Fine. So these are some of the parameters which we will understand mathematically and conceptually. Next is the input-output organization. Input-output organization means that how the computing system interact with its input and output devices. So assessing input-output devices, interrupts are there, interrupts hardware are there, and enabling and disabling interrupts. This is important, and handling multiple devices. So we will have to prioritize the interrupts actually. Then we will find that which devices need to operate first, and then we will find the hierarchy of the input output system, that how they can be controlled by the microcontroller or microprocessor. So controlling device request, exception, direct memory access, and buses. So these terms we will understand in unit 3. Interface circuits, standard input output interfaces, PCI bus, SCSI bus, USB bus. We will understand these protocols by means of interface circuits and how they work actually. So this is about the unit 3. Next is unit 4, and in unit 4 we will understand memory system basic concept, the types of the memory, which type of the memories we have, RAM, ROM, EPROM, and these type of the memory we have, and we will understand that what is the speed, size, and cost of the memory, and on the basis of speed, size, and cost we will define the you can say we will find some differences in the memory, and the memory hierarchy is important, that first is the cache memory, then your storage memory, your SSD, hard disk drive, optical memory, these type of the hierarchical memory hierarchy we will learn about these things, and locality of reference, cache memory, mapping functions, replacement algorithm. So there are some replacement algorithm also whenever we have to change our data. So then replacement algorithm are there. So effective access time and hit ratio, virtual memory paging, advantages and disadvantages of paging, and virtual memory, segmentation, because we have a large memory, then we have to segment it, and in the different domain. So paging combined with segmentation, different type of the pagings are there, and different types of the pagings, and pagings are combined with the segmentation. real world example of the memory management. And Pentium 4 is the processor, how this Pentium 4 work in the memory work with the memory management algorithm. So we will learn about these things in unit 4. In unit 5 we will learn about the introduction to alternative architectures, which are little advanced. So RISC type machine, we will understand RISC type machine, Flynn's taxonomy, parallel and multiprocessor architectures, instruction level pipelining, and superscalar VLIW architectures, vector processors, and interconnect networks, shared memory multiprocessor. It is important whenever we are going to deal with the you can say cloud computing. Then it is an important topic whenever we are going to deal with the cloud computing concept, and closely and loosely coupled multiprocessor systems, and alternative parallel processing approaches, and data flow computing and neural networks. So these things we will learn about to understand the alternative architectures which are present in our domain. So textbook we will refer William Stelling's Computer Organization and Architecture. It is your textbook, you can refer it. I will also refer this book for many topics in your syllabus. And in Karl Hamacher we will and computer organization we will understand this. We will take these two books to cover our syllabus, and beyond this we will cover also the David F. Patterson, John L. Hennessy, Computer Organization and Design. And if you need to discuss about the ARM processor and architecture and hardware, then you can go with the David F. Patterson and Linda Null, Julia Leber, Computer Organization and Architecture, Jones and Berkeley Publishers. So 2003 edition, we can have some of the topics from this book also. So it's enough for your that mode of the evaluation is the test, assignment and midterm exam, and midterm exam and lab, and term exam and lab exam. So these all things will provide the mode of evaluation for your given course. And thank you for this lecture. Thank you.